Hi guys, in today's class, we are dealing with our subject for today is chemistry, and our topic for today is coordination compound. Our topic for today is coordination compound. So now, given the complex ions, copper. Here is copper. This is the complex ions. Here is copper. I think this guy is we call this guy metal ions, central metal ions. Then this guy is called the ligand, ammonia. This guy here is called the ligand. Then here is my ions. So now, um, when we are talking about coordination compound, we are talking about complexes. When we talk about coordination compound, we are talking about complexes. So now, the question says, what is the coordination number of the complex ions? 2. Give the atomic name of the complex ions. 3. What is the oxidation state of the central metal ions? Then 4. What is the shape of the complex ions? So now, let's take the solution. So now, the first one says, what is the coordination number of the complex ions? And I told you earlier. Please, when we are talking about the coordination number, we also refer it to as secondary valency. Coordination number is also referred to as secondary valency. And remember, coordination number is that number multiplied with the ligand. If you look at it, here is the ligand. If the ions is called the ligand, and then the number is multiplied with that ligand is 4. So, day 3, 1. Day 3, our coordination number, the coordination number equals to 4. From the complex, from this guy. Because I told you earlier, coordination number is that number that is multiplied with the ligand. Coordination number is that number multiplied with the ligand. So now, here is my ligand. This is okay. Let me show you something. Here is copper, here is ammonia, multiplied with 4, then here is the iron. So now, this guy here, this guy is called central metal ions. Then this guy here is called the ligand. Here is the ligand. So now, what do I mean by ligand? Ligand is that ion or atom that binds with the central metal ions to form the coordination complex. Ligand, this is the ligand, ammonia, is that ions or molecules that binds with the central metal ions to form the coordination complex. Okay, so now let's move back to our question. So our first question is coordination number. So we have got the question here. 4. The number multiplied with the ligand is our coordination number or our secondary valency. So now the next question says II. Give the atomic name of the coordination complex. So now in this case, we have to name this coordination complex. And remember, when you are naming any coordination complex, please start from the ligand to name. Always start from the ligand. We name the ligand first. Anytime you are naming a coordination complex, this man, we treat this man first. So now, and here is 4. Remember, when we are naming chemical, if you can recall, when we are naming chemical compounds, for example, chemical compound, for example, if I have H2SO4, H2SO4, this is a chemical compound. Why is called, this one is called coordination compound. So now, if I want to name this chemical compound, I'll start with this guy. That will be tetraoxosulfate. Tetra, because it is 4. Tetraoxosulfate 6 acid. Tetra. Then in this case, now it is 4. Don't be confused. In chemical compound, we use tetra to represent 4. But whereas in coordination compound, we are using tera, not tetra. We are using tera, not tetra. So now, when naming this, the name of this compound is tera. This is how Tera is written. Tera, not Tetra. Tera. So now this 4. That is the first name. Tera. You now need to go to this guy. That will be Tera. This Amine. And then in this case, we name it as Amine. Amine. That will be Tera, then Amine. Document. Amine. Then before you now move to this guy, you now move to central meter ions. When you are done naming ligand, I'm done with the ligand now, which is the amine. This 4 is this Tera. And then I want to name my metal and central metal ions, which is my copper. So then you will now put copper. Copper. And because this oxidation states of 2, so that will be copper 2 ions. Copper 2 ions. So now that's the name of this complex. Tera and B copper 2 ions. Then the next one says, what is the oxidation state of the central metal ions? You are looking for this guy. Oxidation number of this guy. When we are talking about oxidation states, we are talking about oxidation number. At the same time, if you are talking of oxidation states, we refer to as primary valence. So now, how do you calculate oxidation states? This is how it goes. So now, we're calculating, let's bring this formula. This formula says copper into ammonia, here is 4, heat vacuum, here is +2. Remember, indices, multiplication means addition. So now, this formula can be written as copper plus into ammonia 4. The power equates, that will be equal to +2. So now, I'm looking for the coordination number of this guy. I'm looking for this guy. So now, I can say that let copper equals to what? X. I'm looking for copper. I can say that let copper equals to X. So from here, I can say that X plus material. If you want to know the oxidation number of this guy, because some people are always confused, yes, because I can remember in our time when I was in this is the parts that normally confuse my people. Yes, these parts actually confuse them, but I give them a method so that whenever they see any correlation compound they ask them to solve for oxidation number, they go with that method. So you right there, please follow up, go with this method. So look at this. Here is nitrogen, here is hydrogen. Please, for you to know the oxidation number of nitrogen, look at what is multiplied with hydrogen. You are having them. That means oxidation number of nitrogen here is what? 3, because 3 is multiplied. Remember, hydrogen is +1. Oxidation number of hydrogen is what? +1 or -1. Hydrogen is -1 when it's in hydride state. So now if you look at this molecule, at this point, hydrogen now is in hydride state. So that means hydrogen pH -1. So if you say now, -1 times 3, that will be 3. So therefore, this guy is stable with this guy. So from there, since 3 is multiplying them, I can say that means nitrogen is what? +3. Nitrogen is +3. Then hydrogen, I told you earlier, when hydrogen is used in reactions, it is hydrate, undergoes hydration, and then at that point, that hydration, the oxidation number is what? -1. So -1 times 3, that will be -3 or 4 equals to what? +2. So now if you look at this, +3 minus, that's 3 minus 3 is 0. So 0 times 4 is 0. So this minus 1. I can say that x plus 0 equals to what? 2. So this guy cancels out. I can say that x equals to what? +2. Final answer. So my people, but x equals to what? But x equals to copper. Then copper equals to what? +2. Final answer. So now, the oxidation number of this guy is +2. So our next question says, what is the shape of the complex ions? shape of the complex ion. So what do? You quickly draw this guy because I told you earlier, this guy is called the central metal ions. Central metal ions. This is it. That means this guy must be at the center. Okay, this guy, you bond this guy to this. This guy must be at the center. Then you bond this one to it because they say what is the shape. So what do? Take the shape, take the shape of the molecule. So our copper is our central molecule. So here will be our copper, my copper. Then if you look at here, I'm having four times four ammonia. That means I should bond 4 ammonia to this guy, to the central metal ions. So I can bond it to ammonia. Here will be ammonia. Then here will be ammonia. Then here will be what? Ammonia. Then here will be ammonia. So now it's complete now. If you look at 1, 2, 3, 4, that's how you see 4. It's complete. So if you want to know, take the shape of this guy, because you are having 1, 2, 3, 4. Remember, carbon is what? Tetravalence. So if you look at this is tetravalence molecule. So you can say this shape is called tetrahedral shape. We call the shape tetrahedral. So the shape is called tetrahedral. So, my people, this will begin our class for today. Thank you. God bless you. Stay informed as we continue in our next class. But remember, I still remain your instructor.